Hello students, I Dilip Kumar Jain, PGT Physics, केवी नंबर 1 उदयपुर। आज मैं आपको चैप्टर नंबर 2 इलेक्ट्रिक पोटेंशियल एंड कैपेसिटेंस की एनसीईआरटी एक्सरसाइज का सॉल्यूशन करवाऊंगा। तो स्टार्ट करते हैं। पहला क्वेश्चन नंबर 1, 2 charges 5 into 10 to power minus 8 coulomb and minus 3 into 10 to power minus 8 coulomb are located 16 centimeter apart. At what points on the line joining the two charges is the electric potential zero? Take the potential at infinity to be zero. एक बार और देखिए क्वेश्चन में क्या दिया हुआ है। दो चार्ज दिया हुआ है। एक चार्ज Q1 इक्वल टू 5 इंटू 10 टू पावर माइनस 8 कूलम दिया हुआ है। दूसरा चार्ज जो है वो नेगेटिव है, Q2 इक्वल टू माइनस 3 इंटू 10 टू पावर माइनस 8 कूलम दिया हुआ है। दोनों चार्ज जो है कितने डिस्टेंस पे एक दूसरे से दूर हैं? 16 सेंटीमीटर। मीन्स डिस्टेंस बिटवीन द टू चार्जेस D इक्वल टू 16 सेंटीमीटर इक्वल टू 0.16 मीटर। Now consider a point P on the line joining the two charges as shown in the given figure. In this diagram you can see Q1 and Q2 are separated by a distance D, which is equal to what? 0.16 meter, and we consider a point P between the two charges Q1 and Q2 at R distance from charge Q1. R is equal to what? Distance of point P from charge Q1. Let the electric potential V at point P be 0. What is total electric potential due to charge Q1 and Q2 at point P equal to what? 0. Potential at point P is the sum of potential caused by charge Q1 and Q2 respectively. पॉइंट P पे जो टोटल चार्ज है वो किस किस के कारण से हुआ? एक चार्ज Q1 के कारण और दूसरा Q2 चार्ज के कारण। तो टोटल पोटेंशियल इज इक्वल टू व्हाट? V इक्वल टू V1 प्लस V2। V इक्वल टू V1 इज व्हाट? Q1 अपॉन 4 पाई एप्सिलॉन 0 R प्लस Q2 अपॉन 4 पाई एप्सिलॉन 0 D minus R, where epsilon naught equal to permittivity of free space. For V equal to 0, equation 1 reduced to equal to 0. So what we get? Q1 upon 4 pi epsilon 0 equal to minus Q2 4 pi epsilon 0 D minus R. 4 pi epsilon 0 4 pi epsilon 0 cancel. So what we get? Q1 upon R equal to minus Q2 upon D minus R. Now what we do? We substitute the value of Q1 and minus Q2. So 5 into 10 to the power minus 8 is the value of Q1 upon R equal to minus, now Q2 is what? Minus 3 into 10 to the power minus 8 upon D is what? 0.16 minus R. So 10 to the power minus 8, 10 to the power minus 8 cancel. Then what do you get? 0.16 upon R minus R upon R is what? 1 equal to what? 3 by 5. So 0.16 equal to R equal to 3 by 5 plus 1, which is come to 8 by 5. So R equal to what? R equal to 0.1 m means 10 centimeter. Therefore the potential is 0 at a distance of 10 centimeter from the positive charge between the charges. So what is the position of point P from charge Q2? It is what? 16 minus 10 equal to 6 centimeter. This is the case 1 in which point P is lying between the two charges Q1 and Q2. But now we consider another case, very interesting case. Suppose point P is outside the system of two charges at a distance S from the negative charge, where potential is what? 0, as shown in the figure. So here in the diagram you can see the Q1 and Q2 two charges which are separated by distance D. S is what? Distance of charge Q1 from point P, and distance of Q2 from point P is what? S minus dt. So here one assumption for this arrangement potential is 0 by V equal to Q1 upon 4 pi epsilon 0 S plus Q2 upon 4 pi epsilon 0 S minus D. For V equal to 0, equation 2 reduced to Q1 upon 4 pi epsilon 0 S equal to minus Q2 upon 4 pi epsilon 0 S minus D. So Q1 upon S equal to minus Q2 upon S minus D. Now substitute the value of Q1 and minus Q2. Q equal to 5 into 10 to the power minus 8 upon S equal to minus 3 into 10 to the power minus 8 upon S minus 0.16. So what we get? 10 to the power minus 8, 10 to the power minus 8 cancel, and if we solve this one, S minus 0.18 divided by S means 1 minus 0.16 upon 3 equal to 3 upon 5. So what we get? 0.16 S equal to 1 minus 3 by 5, we come to 2 by 5. So S equal to what? Equal to what? 0.16 divided by 2, 0.4 meter, or equal to 40 centimeter. Therefore, the potential is 0 at a distance of 40 centimeter from the positive charge and outside the system of charges. Very important. Here one assumption, you see, suppose point P is outside the system of two charges at a distance S from the negative charge. This is not negative charge, this is what? Positive charge. Okay, so next question number 2. A regular hexagon of side 10 centimeter has a charge 5 microcoulomb at each of its vertices. Calculate the potential at the center of the hexagonal. अब आपको क्या है? रेगुलर हेक्सागोन में जिसके सब साइड्स जो है वो क्या है? इक्वल है. ए बी इक्वल टू बी सी इक्वल टू सी डी इक्वल टू डी इक्वल टू ई एफ इक्वल टू ए एफ. All 6 sides have length 10 centimeter. Calculate the potential at the center of the hexagonal. The given figure shows 6 equal amount of charges Q at the vertices of a regular hexagonal. So Q equal to 5 microcoulomb, 5 into 10 to the power minus 6. Side of the hexagonal AB equal to BC is 10 centimeter. Distance of each vertex from center O, D equal to what? 10 centimeter. If we join this A, B, C, D, E, F to point O, then we get this 6 lines, 6 vertices, each one forms an equilateral triangle. Okay, electric potential at point O. What is electric potential at point O? V equal to 6 into Q upon 4 pi epsilon 0 D, where epsilon 0 is your permittivity of free space. So 1 upon 4 pi epsilon 0 is what? 9 into 10 to the power 9 Newton per coulomb square per meter square. So V equal to 6 into 9 into 10 to the power 9 into value of Q is what? 5 into 10 to the power minus 6 upon D. D is what? 0.1. On solving we get 2.7 into 10 to the power 6 volt. Therefore the potential at the center of the hexagon is 2.7 into 10 to the power 6 volt. Now next question number 2.3. Two charges 2 microcoulomb and minus 2 microcoulomb are placed at point A and B 6 centimeter apart. यहाँ पे दो चार्ज हैं 2 माइक्रोकुलम और माइनस 2 माइक्रोकुलम जो एक दूसरे से 6 सेंटीमीटर की डिस्टेंस पर है. आइडेंटिफाई एन इक्विपोटेंशियल सरफेस ऑफ द सिस्टम. इक्विपोटेंशियल सरफेस मीन्स एक ऐसी सरफेस आपको फाइंड करनी है जिसके हर पॉइंट पर इलेक्ट्रिक पोटेंशियल क्या होगा आपका? सेम. B, what is the direction of electric field at every point on this surface? और इस इक्विपोटेंशियल के सरफेस के हर पॉइंट पर उसका इलेक्ट्रिक फील्ड का डायरेक्शन क्या होगा? तो अपन को दो चीजें निकालनी है. देख, सिचुएशन इज रिप्रेजेंटेड इन गिवन कंडीशन. A and B are two charges 2 microcoulomb and minus 2 microcoulomb, and equipotential surface is the plane on which total potential is 0 everywhere. This plane is normal to the line AB and the plane is located at the midpoint of line AB. Because the magnitude of charges is the same, so this distance must be equal because charges are what? Negative. So this equipotential surface is perpendicular to the line joining two charges A and B, and it will pass through the midpoint of the line joining A and B. Now, second part, the direction of the electric field at every point on the surface is normal to the plane in the direction of AB. Now, direction of the electric field at every point on this surface is normal to the plane in the direction of AB. How? AB, if we put a positive charge at the midpoint due to 2 microcoulomb, it will get a repulsive force towards AB, and due to minus 2 microcoulomb, it will get a force again in the direction of AB, which is due to the electrostatic attraction. So net force is in the direction of AB. So direction of the electric field at every point on this surface is normal to this plane in the direction of AB. Now next question number 2.4. A spherical conductor of radius 12 cm has a charge of 1.6 into 10 to the power minus 7 coulomb distributed uniformly on its surface. What is the electric field inside the sphere, just outside the sphere, and at a point 18 cm from the center of the sphere? Very careful. We are studying the chapter electric potential and capacitance, but in question what is electric फील्ड? इलेक्ट्रिक फील्ड पूछ रहे हैं, इलेक्ट्रिक पोटेंशियल नहीं पूछ रहे हैं. तो देखिए एक स्फेरिकल कंडक्टर है जिसकी रेडियस कितनी है 12 सेंटीमीटर है और उसके ऊपर चार्ज दिया हुआ 1.6 into 10 to the power minus 7 कूलम इनसाइड द स्फीयर. इनसाइड द स्फीयर में क्या होगा? क्योंकि कोई भी एक आपका स्फेरिकल कंडक्टर उसके अंदर चार्ज नहीं रह सकता है, तो इस कारण से देखिए रेडियस ऑफ द स्फेरिकल कंडक्टर इज 0.12, charge uniformly distributed over the conductor Q equal to 1.6 into 10 to the power minus 7. Electric field inside a spherical conductor is 0. This is because if there is field inside the conductor, then charge will move to neutralize it, or we can say that the charge cannot reside inside the conductor. Charge distributed to any conductor, it will remain always on its surface. If you read the question, you will get the same thing. A spherical conductor of radius 12 cm has a charge of 1.6 into 10 to the power minus 7 coulomb distributed uniformly on its surface, not inside the surface. Okay, so there is no charge inside it, so electric field is what? 0. Now next one, electric field E just outside the conductor is given by the relation E equal to 1 upon 4 pi epsilon 0 Q upon R square, where epsilon 0 is permittivity of free space. So 1 upon 4 pi epsilon 0 is value we know 9 into 10 to the power 9 Newton per meter square per coulomb square. E equal to 1.6 into 10 to the power minus 7 into what is charge? 9 into 10 to the power minus 9 coulomb upon. Now actual radius of the spherical conductor is 0.12 square. On solving, we get 10 to the power 5 Newton per coulomb. This is the electric field on the surface of spherical conductor. Now C part, electric field at a point 18 meter from the center of the sphere. 18 meter is not, it is 18 centimeter from the center of the sphere. Even distance of the point from the center D equal to 0.18 centimeter. Now this distance D is greater than radius of the conductor, so all the charge distributed on the surface of the conductor is centroid at the center of the spherical conductor, so it becomes now point charge. So E1 equal to 1 upon 4 pi epsilon 0 Q upon D square, 9 into 10 to the power 9 into 1.6 into 10 to the power minus 7 upon 18 into 10 to the power minus 2 whole square on solving 4.4 into 10 to the power 4 Newton per Coulomb. Therefore, the electric field at a point 18 centimeter from the center of the sphere is 4.4 into 10 to the power 4 Newton per Coulomb. Now, next one, question number 2.5. A parallel plate capacitor with air between the plates has a capacitance of 8 picofarad. Okay, 1 picofarad is 10 to the power minus 12 farad. What will be the capacitance if the distance between the plates is reduced by half and the space between them is filled with a substance of dielectric constant 6? Here value of K is what? Given 6. Capacitance between the parallel plates of the capacitor C equal to 8 picofarad. Initially distance between the parallel plates was D and it was filled with the air. Dielectric constant of air A equal to 1. Capacitance C is given by the formula C equal to K epsilon naught A upon D, or K equal to what? 1. So we get C equal to epsilon naught A upon D, where area of each plate, epsilon naught is permittivity of free space if distance between the plates is reduced to half. Then new distance D dash equal to what? D by 2. Dielectric constant of the substance filled in between the plate K equal to what? 6. Hence, capacitance of capacitor becomes C dash equal to K dash epsilon naught A upon D dash. Now, what is K dash? 6. Epsilon naught A upon D dash is what? D by 2. Taking ratio of equation 1 and 2, we obtain C dash equal to what? 12C. And value of C is what? 8 picofarad. So 12 into 8 equal to 96 picofarad. Therefore, the capacitance between the plates is 96 picofarad. Now, question number 2.6. 3 capacitor, each of capacitance 9 picofarad are connected in series. What is the total capacitance of the combination? What is the potential difference across each capacitor if the combination is connected to 120 volt supply? अब देखिए इस क्वेश्चन के अंदर 3 कैपेसिटर है C1, C2 and C3. All 3 capacitor is equal to what? 9 picofarad connected in series. तो total capacitance निकालना है और potential difference across each capacitor. Capacitor of each of 3 capacitor C equal to 9 picofarad. Equivalent capacitance C dash of the combination of capacitor is given by the relation 1 upon C dash equal to 1 upon C1 plus 1 upon C2 plus 1 upon C3. But C1 equal to C2 equal to C equal to what? C. So 1 upon C dash equal to 1 upon C plus 1 upon C plus 1 upon C. Value of C is what? 9. 1 upon 9 plus 1 upon 9 plus 1 upon 9 equal to 3 upon 9 or equal to 1 upon 3. So 1 upon C dash equal to 1 upon 3. C dash equal to 3 micro picofarad. Therefore, total capacitance of the combination is 3 picofarad. You see in the question it is given picofarad, so answer will also come to picofarad only. Supply voltage V equal to 100 volt. Potential difference V across each capacitor is equal to 1/3 of the supply voltage. So V dash equal to V by 3. 120 by 3 equal to 40 volt. Therefore, the potential difference across each capacitor is 40 meter. देख लीजिएगा यहाँ पे 3 माइक्रोफेरेड लिखा हुआ है, टाइपिंग मिस्टेक है, इट इज 3 पिकोफेरेड. Question number 2.7. 3 capacitors of capacitance 2 picofarad, 3 picofarad and 4 picofarad are connected in parallel. What is the total capacitance of the combination? C1 equal to 2 picofarad, C2 equal to 3, C4 equal to 4 picofarad. And now these 3 capacitors are connected in what? Parallel. B part, determine the charge on each capacitor. What is the charge on C1? What is the charge on C2? What is the charge on C3? 3. How to solve? Is just to see capacitance of given capacitor are C1 equal to 2 picofarad, C2 equal to 3 pico, C3 equal to 4 picofarad. For the parallel combination of the capacitor, equivalent capacitance C dash is given by the algebraic sum. C dash equal to C1 plus C2 plus C3. So C dash equal to 2 plus 3 plus 4 equal to 9 picofarad. So therefore total capacitance of the combination is 9 picofarad. B. Now supply voltage V equal to what? 100 volt. The voltage through all three capacitor is same, V equal to 100 volt. In parallel combination, potential difference remains same, but charge across each capacitor may be different. So how to find the charge across any capacitor with the potential V? Q equal to CV. So charge Q1 equal to what? C1V. Here C is what? 2 picofarad. Charge Vc equal to 100 into 2 equal to 2 picocoulomb. 2 picocoulomb is 10 to the power minus 12. So 2 into 10 to the power minus 10 coulomb. For C2, which is C equal to 3 picofarad, charge is CV equal to 100 into 3 equal to 300 picocoulomb, or 3 into 10 to the power minus 10. For C equal to 4 picofarad equal to charge equal to Vc, or equal to 100 into 4 equal to 400 picocoulomb. Small correction is there. Not 400 into 4 equal to 400 picofarad. 4 into 10 to the power minus 10 coulomb. So now we already solved question 7. Now next move to question number 8. Very important question. In a parallel plate capacitor with air between the plates, each plate has an area of 6 into 10 to the power minus 3 मीटर स्क्वायर. देखिए पैरेलल प्लेट कैपेसिटर के अंदर एरिया ऑफ प्लेट दिया हुआ है A इक्वल टू व्हाट 6 into 10 to the power minus 3 मीटर स्क्वायर. The distance between the plate is 3 mm. 3 mm means D equal to what? 3 into 10 to the power minus 3 meter. 3 millimeter means 3 into 10 to the power minus 3 meter. Calculate the capacitance of the capacitor. If this capacitor is connected to a 100 volt supply, what is the charge on each plate of the capacitor? Very simple question. Area of each plate A equal to given, distance D equal to given, voltage V equal to given. So capacitance C of a parallel plate capacitor is given by C equal to epsilon naught A upon D, where epsilon naught is permittivity of free space and we know the value of free space 8.85 into 10 to the power minus 12. On substituting the value of epsilon naught 8.85 into 10 to the power minus 12 into area is 6 into 10 to the power minus 3 upon D. 3 millimeter is 3 into 10 to the power minus 3. On solving we will get 17.71 or 10 to the power minus 12 farad or 17.71 picofarad. Now what is the charge on the capacitor? V equal to what? Q upon C. So Q equal to what? Vc. V is what? 100 volt into 17.71 into 10 to the power minus 12. So we get 17.7 into 10 to the power minus 10, or in scientific notation we write 1.77 into 10 to the power minus 9 coulomb. Therefore capacitance of the capacitor is 17.71 picofarad and charge on each plate is 1.771 into 10 to the power minus 9 coulomb. Now next question number 2.9. Explain what would happen if in the capacitor given in the exercise 2.8 a 3 mm thick mica sheet of dielectric constant 6 were inserted between the plates while the voltage supply remained connected. B after the supply was disconnected. So in this one the mica sheet having dielectric constant K equal to what? 6. Initial capacitance is what? 1.77 into 10 to the power minus 11 farad. Now this 3 mm mica sheet distance is what? D is also 3 mica. So the space between two plates of the capacitor is fully filled with the mica sheet. So now new capacitance is what? C dash equal to kc, 6 into 7, 1.77 into 10 to the power minus 11, or 106 picofarad. Supply voltage V equal to 100 volt. New charge Q dash equal to C dash V equal to 6 into 1.77 into 10 to the power minus 9, or we get charge 1.06 into 10 to the power minus 8 coulomb. Potential across the plates remains 100 volt. Now in second condition, if we remove the battery, then what happen? Dielectric constant K equal to 6, initial capacitance is given, new capacitance will be same C dash equal to, but if supply voltage is removed, then there will be no effect on amount of charge in the plate, but potential difference will be reduced. How it will be reduced? Before it is 100 volt, now what happen? You can see potential across the plate is going to V dash equal to Q upon C dash, 1.771 into 10 to the power minus 9 upon 106 into 10 to the power minus 12, 16.7 volt. Very important. Okay, when here two conditions, one is battery is connected and second is what? Battery is not connected. In both condition, capacitance will be increased by K times, charge will be remain same, but in first condition voltage remains same 100 volt, but when battery is removed, the potential difference across the two plates of the parallel plate capacitor is what? 16.7 volt only. Very important. Now next, question number 2.10. A 12 picofarad capacitor is connected to a 50 volt battery. How much electrostatic energy is stored in the capacitor? Okay, what is given? C is given 12 volt, 12 picofarad, 12 into 10 to the power minus 12 farad. Potential difference V equal to 50 volt. Electrostatic energy stored in the capacitor is given by the relation E equal to 1 by 2 CV square equal to 1 by 2 into 12 into 10 to the power minus 12 into V. V is what? 50 square. On solving, we will get 1.5 into 10 to the power minus 8 joule. Therefore, the electrostatic energy stored in the capacitor is 1.5 into 10 to the power minus 10 joule. Now, last question 2.11. A 600 picofarad capacitor is charged by 200 volts supply. It is disconnected from the supply and is connected to another uncharged 600 picofarad capacitor. How much electrostatic energy is lost in the process? See, फर्स्ट क्या है आपके पास में एक 600 पिकोफेरेड कैपेसिटर है जिसको 200 वोल्ट्स आपने चार्ज किया है. उसके बाद में उसको सप्लाई से डिस्कनेक्ट करना है. डिस्कनेक्ट करके दूसरा आइडेंटिकल 600 पिकोफेरेड कैपेसिटर्स के कांटेक्ट में लाना है और इस प्रोसेस के अंदर कितने इलेक्ट्रोस्टैटिक एनर्जी का लॉस होता है वो अपन को फाइंड करना है. तो देखिए, कैपेसिटेंस ऑफ द कैपेसिटर C इक्वल टू 600 पिकोफेरेड, potential difference V equal to 200 farad volt. Electrostatic energy stored in the capacitor is given by E equal to 1 by 2 CV square. So this is what? Initial energy 1 by 2 into C 610 to the power minus 12 into voltage is what? 200 square. What we get? 1.2 into 10 to the power minus 5 joule. Now, if supply is disconnected from the capacitor and another capacitor of capacitance C equal to 600 picofarad is connected to it, then equivalent capacitance C dash of then combination is what? 1 by 1 series combination. 1 upon C dash equal to 1 upon C plus 1 upon C, 1 upon 600 plus 1 upon 600, we will get 2 upon 600, 1 upon 300, or equivalent capacitance C dash equal to what? 300 picofarad. New electrostatic energy can be calculated as E dash equal to 1 by 2 C dash V square, 1 by 2 equal to 300 into 200 square. On solving, what we get? 300 picofarad. 200 picofarad means 300 into 10 to the power minus 12 into 200 square. On solving, we will get 0.6 into 10 to the power minus 5 joule. Previously it is what, 1.2 into 10 to the power minus 5 joule. Now what we are getting, 0.6 into 10 to the power minus 5 joule. Loss in electrostatic energy is what, initial energy minus फाइनल एनर्जी. स्टार्टिंग में कितना देखो 1.2 into 10 to the power minus 5 माइनस फाइनल क्या है 0.6 into 10 to the power minus 5. 1.2 minus 0.6, what we get, 0.6 into 10 to the power minus 5 or 6 into 10 to the power minus 6 joule. Therefore electrostatic energy lost in the process is 6 into 10 to the power minus 6 joule. Thank you.